I want you guys to jot this down. Lesson 18, projectile at an angle. We'll be able to use vectors to calculate projectile motion. Today's fact, today's engineer, this looks like it's way more than 100 words, but we can have a quick look at this. This is written by Dylan. This is about Robert Kearns. He passed away in 2005, but was born midway through the 20th century. Born on the 10th of May 1927, he passed away on the 9th of February 2005. Robert Kearns, famously known as the invention of the windshield wiper system with intermittent operation, which was invented as a system that was more efficient than the current windshield wiper system. Now, that's the point. This is the point that I usually make when someone talks about this. He didn't invent the windshield wiper. He did not invent the windshield wiper. That was actually invented by a woman years before. He made the intermittent one. Intermittent one means that it swipes once, waits 3 seconds, swipes again, waits 3 seconds, rather than continually swiping. This way worked was unlike the previous ones, constantly kept swiping, slowing down, or speeding up. The system had introduced the idea of having momentary stops of motion, where there was gaps between each swipe, such as a 3-second gap. Yeah, Dylan just explained it for us. Thank you. This is more efficient because it allows less energy to be used up by allowing some rain on the wind or whatever is on the windshield to build up before wiping it, but not to the point where you can't see, which saves more resources. Unfortunately, the companies Ford and Chrysler had tried to steal this idea and spend years in a lawsuit and case against Robert Kearns, which went on for years and years. In the end, unfortunately, Robert Kearns had won a multi-million-dollar case which gave him back his rightful ownership of the windshield wiper system with intermittent operation. Unfortunately, Robert Kearns passed away on the 9th of February 2005 at the age of 77. Because of Robert Kearns, modern-day cars have more efficient windshield wipers, which may not seem like a big advancement, but had saved some abundance of resources accumulated over years, which were put to use in other things to provide constant fight of survival against the world of efficient technology. Okay, so my point that I think like about Robert Kearns, and I think what Dylan sort of agreed with, is this. Firstly, his ideas were stolen, not just by any people, but by companies. And this is the other one that I haven't talked about with regards to stealing ideas. Companies love stealing little people's ideas, and because they're so big, they can usually win. In this case, Robert Kearns fought for a very, very long time and actually won, and actually could prove, yes, this thing is an invention of mine. I sold it to them, and then they stole it. So, well, they stole it because even though I didn't, talk to them about it. So, and it's usually very rare that someone wins. And yeah, you're right. It's not very. You wouldn't think this is a revolutionary thing, but if you think about every single car pretty much on the planet has intermittent wipers now, that's pretty spectacular. To think about that, as well as to look at it as a efficiency thing, that you're saving energy. Anything that saves energy is pretty good too. So yeah, this is still pretty good. It's a little bit long. Dylan, I reckon you could have summarized some of the bits and pieces here, but yeah, it's still has done a very good job of explaining it. Let's talk about projectile motion. Where did we get up to get up to this point where we're at? And what's next? So what we did to get up to this point is we talked about what is projectile motion. We said that projectile motion is the path of an object through the air. It has a horizontal velocity and a vertical velocity. The importance of the horizontal velocity and the vertical velocity is illustrated here. That horizontal velocity is the same. It's always the same measurement. Whilst at the same, the vertical velocity gets bigger and bigger and bigger and bigger and bigger. And this increase in size of our vertical velocity is because it gets accelerated by gravity. The gravity and that acceleration we know is -10. So therefore, it builds up by 10 meters per second every second. You can see that here as well. you can see that it gets negative 20, negative 30, negative 40, negative 60, and it gets bigger and bigger and bigger. Actually, at the very start, though, it doesn't get bigger. It actually slows the upwards velocity down, and there reaches a point at the very tip where you have a 0 upwards speed. You have no upward speed and you have no downward speed. That's 0 after a split second. So that's going to be really important when we calculate certain things. What were those things? Well, we looked at vertical motion. We just said, well, let's look at the vertical motion of an object being dropped off a building. We actually explored using these two formulas. These two formulas proved to be very useful for us. So, and we kind of use these formulas, pretty much only these formulas when it comes to projectile motion. So we figured out that the velocity increases at an increasing rate, whereas the displacement just shot through the floor essentially very, very quickly. And then we were able to look at the formula. This formula we can pull over here, and this is a formula that tells us the height of an object, in this case x, which is still the displacement. But in this case, because we're looking up and down, we also think it as the height. And how that changes over time. You see, as time goes forward, the height goes up, but then after a while, the height starts to come down. And the shape that it makes is a parabola because of t squared. Because that time is squared, it's going to make a parabola. And it's actually, because it's a negative, it actually makes an inverted parabola. The reason it's negative is because the acceleration is negative 10. So it actually makes a parabola. Now, if you're not comfortable with parabolas because you haven't studied them, that's okay. You just need to know it makes a x squared shape. Now, we then did some examples. We looked at this example here, and we still used our two formulas, x equals ut plus half at squared, and we used v equals u plus at. We found out 4 facts. We found out how long the time to the peak height, how long did it time to get to the peak height, how long was the total time, we looked at in the air, we looked at how high it goes, and then we went with, the last thing we looked at was how far. Now the attendance question, by the way, was an example of this one here. No, not that one there, whoopsies. This one here, how high it goes. And to do that, we need to work out these first two before you can really work out how high an object goes, or at least the first one, because we're not going to be solving necessarily these types of questions. The very end of the lesson we did was this question, these questions here. I found out by accident this one was actually a little bit too hard for you guys to be expected to do. But that first one was another example of finding out the time it takes. Now, what we're going to do today is we're going to really ramp this up. This, ladies and gents, here, we're going to do this example. I've set the whole lesson aside to do this, so we've got 30 minutes to do it. This question is, in many ways, this question that I'm going to hit you guys with is the hardest type of question that I could give you guys in engineering maths. It's a combination of everything, and it's kind of difficult because essentially what I'm going to do is I'm going to take all the knowledge that you guys just learned, all those pieces of information that we just learned about projectile motion, and I'm going to wrap it up into another layer that you've got to unwrap first. So you're going to unwrap that outer layer before you can get to the inner layer. And yeah, so I'm not actually adding anything to the projectile motion stuff. I'm just adding some stuff outside of it. Let me show you what I mean. The question that we're going to focus on today, and this is the only question that we're going to do, is this one here. A car drives up a ramp at 10 meters per second at an angle of 30 degrees from the horizontal. How high will the car go? How long will the car be in the air? And how far will the car travel horizontally? This is the hardest question that I think that I could give you guys. So let's get started. First thing I'm going to do is I'm going to put up the two equations that we're going to use, which are x equals ut plus half at squared. And I'm also going to put down v equals u plus at. And just so that I remember, and just so that you guys remember, a is going to be -10. No matter what we do, a is going to be -10. Then we're going to start to tackle the question. So we need to know what our upwards velocity is. And we go, a car drives up a ramp at 10 meters per second at an angle of 30 degrees from the horizontal. Great, cool. The upwards, oh, that's all the information it gives us. There is no upwards velocity. You guys might say 10 meters per second. No, that's not an upwards velocity. Let me show you what that looks like. Here's the ramp. Here is 30 degrees. That 10 meters per second is the speed that the car goes up this ramp. That is not the speed, that is not our vertical velocity, that's the velocity up the ramp. What we need to do, and remember I told you that there was an extra layer that we had to unwrap first. What we need to do is we need to find the initial speed vertically and the initial speed horizontally. How do we find those out? Well, we need to use our good friend trigonometry. We need to take this vector, this 10 meters per second vector, and resolve it into its components, into its I and J components. And this is why, remember at the start when I said projectile motion is all of the different techniques meshed into one. Now I'm only going to do one question like this once, but I guess the reason I'm showing you this question is this is like the you know the end of a good song where all of the music comes together, all of the beats that have been playing before, all of the melody, all of the rhythm, all of the rhyme comes into one specific part. And that's what this question represents. It represents all of the knowledge that you've learned. So we're going to start with vectors first, which is the very first thing that we learned. What we need to do is we need to get uy and ux. Well, to do that, we're going to label this guy. We're going to label this the opposite side, the adjacent side, and the hypotenuse. And we're going to start with uy. So I'm going to do that maybe in purple. Yeah, we'll do purple, whatever. So we've got the opposite and the hypotenuse. That's what we need to do to get uy. So if you go opposite and hypotenuse, which one, ladies and gents, we quickly open the chat and yell out to me in chat, what is opposite and hypotenuse? Which identity is that going to be? Come on, guys, it shouldn't take you very long. Go.
Sin.
What was that?
Sin.
Hand.
Sin.
Sin. Sorry, sine or sin. Yeah, opposite hypotenuse. I thought you said tan. We got nervous there. Sin, sine theta. Man, I would never convince students to say, you know, sine, but that's what it's technically called. Sine theta equals opposite over hypotenuse. We want to know that opposite side. So h times sine theta is going to give us our opposite side. Our opposite side, now we're going to substitute. Our opposite side is uy, but I'm actually going to put this on the other side. uy is equal to h, in this case is 10, times sine 30 degrees. Put that in your calculator and you will get 5 meters per second. That is our vertical speed. Now, you could then stop here and you could then start the rest of the question, but I'm actually going to do one less extra little thing here. I'm actually going to spend just the extra effort while I've got my calculator out doing this. I'm going to say cosine theta. I'm not going to use green. because that will not be legible. I might use dark blue. Yeah. Cosine theta equals adjacent over hypotenuse, which means that the adjacent side is equal to h times cosine theta, which means that we end up with 10 times cosine 30, which is equal to, I need to actually get my calculator for this one, 10 times cosine 30 equals 8.66. 8.66 meters per second. And that's going to be useful for us later on, by the way. That is our u of x. That's our initial velocity in the x direction. And it might seem like a little bit of a waste of time at the moment because we don't need to know that one. But, you know, it's always good to know, have that in your back pocket, just to do it. And I always suggest just do that at the start. Now, ladies and gents, at this point here, we are now at the same point that we were with our other questions. We've got an initial speed upwards and an initial speed to the right. That's all you need to solve one of these questions. Now, let's do that solution here. So I'm going to work on that now. We're going to work out, first thing we're going to work out, and this is pretty much the thing that you should work out for any kind of, anytime you've got something that's going up into the air, if you're dropping something off a building, it's going to be a bit different. But for us, because we've got something going up into the air, we need to look at this first thing. We need to look for the time to get to the peak. How long does it take for our car to go up? How long does it take to get to this peak height? Believe me, it's not going very fast vertically, so I don't think it'll be a very, very fast, very, very long time. But we can calculate that time to get to the peak. Let's work that out. The time to get to the peak in this case is going to be equal to, time to get to the peak is going to equal to, well, how do we calculate that? We want to look for t. We've got our initial speed upwards now, that's 5. We know that the final speed at the we know our acceleration, by the way, that's going to be -10. And we know that the speed upwards at the top of the arc is 0. When it gets to at the start, it's going 5, then it might go up 4, then it might go up 3. At the very, very top, it goes 0. Then it's going to start going down, -1, -2, so on and so forth. So therefore, we know that our final speed is 0. We're going to use this formula, V equals U plus AT. In this case, V is 0, a U is 5 plus -10 times T. 0 equals 5, take away 10T. 10T equals 5. T equals 5 over 10 or 0.5 seconds. And again, ladies and gents, that's not one of the questions. That doesn't tell us how high it is or how long it's in the air or how far it travels. But this fact that it takes 0.5 seconds to get from the top of the ramp to the top of its peak is going to be really important for us for all of these other questions. So the next part of that guess would be to then say, well, let's work out how high the car goes. Now we have an idea. How do we do that? Well, now we have an idea of how long it spends in the air. We know that t equals 0.5. We know that our initial speed, u, is 5 meters per second upwards. We know that our acceleration is -10. And so we want to know what x is. We want to know how high that goes into the air. We can use this formula here to get our displacement upwards or our height. X equals ut plus half at squared equals 5 times 0.5 plus a half times -10 times 0.5 squared. Now I'm going to shove all of that straight into my calculator. 5 times 0.5 plus 0.5 times -10 times 0.5 squared. If you put all that into my calculator, I get 1.25 meters. And so that's how high our car goes. So it goes, how high does our car go? 1.25 meters. That's our very first answer. We've gone through a lot of effort to get that very first answer, but you know, it's still, that's pretty good. But now actually all the other answers are going to be really quick and easy to do. Next question, how long does it spin in the air? Well, if it spins 0.5 seconds to get to the peak, it's going to take another 0.5 seconds to get to the ground. So the total time in the air, T total, the total time in the air equals 2 times the peak time. And again, remember, the reason we're able to do this is because it is symmetrical. If it wasn't symmetrical, we wouldn't be able to do this. But yeah, let's just do 2 times TP. 2 times 0.5 equals 1 second. It takes one, it only spends 1 second in the air, which is not very long, but you know, it is a monster truck. So, well, actually, it doesn't even say it's supposed to be a car. It's a car that's, you know, maybe 1 second might be a long time. I mean, we're only going 10 meters per second. 10 meters per second is, what's that? 10 meters? You know what? I'm not going to do that now. Now, how far will that car travel horizontally through the air? Well, this is the very last thing we need to do. To calculate how far something goes through the air, what you would do is you do this. I don't know where to do it. I'm out of space here, ladies and gents. Normally I would do this on a whiteboard and I would have lots and lots of space to write. But because I'm doing this, and I've stupidly left this picture in the way, but you know, we're just going to deal with it. How long does it spin in the air? Well, therefore, our distance, our displacement equals our speed in the x direction times time in the x direction. The reason we don't use x equals ut plus half at squared is because our acceleration left and right is 0. We do not speed up to the left or right. If you want to think about it, you can think about it as using this formula, except we're going to ignore the back part because we're not accelerating. So what was our speed in the x direction? Well, we've got that written down. 8.6. And how long did we spend in the air? We spent 1 second in the air. So therefore, we will travel 8.66 meters through the air. And ladies and gents, that is the end of, in my opinion, the hardest question that I could give you, and probably the most complicated thing. Now, if you're sitting there being like, whoa, I would never be able to do this, don't worry. I think you'll be able to do some of this if you had me helping you through the question. And by me helping you, I mean giving you a question giving you the questions that lead up to that. Like first, tell me what the initial speed and the horizontal speed left and right are. How long does it take to get to the peak height? So on and so forth. Now, and also that's traveling 10 meters. That's actually a pretty fair distance to travel. So, and that's probably because it's a pretty steep ramp, but still. That's actually all of the, and this is what I love about it, this is all of the skills that you guys have learned. There's a little bit of force, actually there's a little bit of acceleration due to force, there's a little bit of gravity, there's a little bit of kinematics, there's a lot of kinematics, and there's a little bit of vectors. So it's a little bit of everything mixed together. There isn't anything really in there about the Newton's third law. I could maybe ask an extra question that says, oh, when it puts a force on the ground or whatever, I could even tell you the mass of the car, but I'm not going to do any of those things. I'm just going to stick to the main ones here. But you do still, the reason we know that A is -10 is because of Newton's second law. But ladies and gents, this is all of the information wrapped up into one question. So I'm going to stop here and quickly ask you guys, is there any parts of this that weren't necessarily 100% clear? Was there any parts where you guys, why did I do this one first? No? Okay, all right, so let's go have a look at, let's just go to here. What were the steps that I would normally do? And I would, maybe you could jot this down here. I've only gone back to here because I've got some more space here. What are the steps that I usually do to solve a projectile motion question? The first thing I want to do is I want to find u of x and u of y, which is my initial velocities. A lot of the time, those are given to you. But in a question like this, those weren't given to us. We actually had to calculate them. The second thing I usually calculate is I use those to calculate the t peak. And that's the time to get to the peak. To do that, I use v equals u plus at. Now, sometimes questions will say, how long did it take to get to the peak height? But sometimes they won't. But you need to have that formula so that you can do anything else. From that formula, you can get two pieces of information. You can get the time, the total time in the air. So you can get, from that piece of information, you can get two things. You can get t total, and you can also get the peak height. The peak height is found by going x equals ut plus half at squared. And the t total can be found by just doing 2 times the peak height. Once you know what your t total is, you can use that to find out your total distance. And you do that by taking that t total, going x equals vt, whereas equals u, well, sorry, let me just rewrite that. X equals u of x times t total. And that's how you can find it out. So those are the main types of questions that you could get. You know, and that's how that's like a flow chart of the order that I usually do to kind of work them out. Now, we're not going to deal with there are other ways, of course. I could give you t total. I could actually give you the time to the peak and then get you guys to work from there. You can't really work backwards. You could work backwards, I guess, if I told you that an object spent 10 seconds in the air, you could use that to like work out. If I told you an object spent 10 seconds in the air, you could use that information to find out how long it was to the peak height. And then if you knew that, then you could probably use that information to work out, you know, what were the different speeds. But it's going to be usually, and most times I give you these types of questions, it's going to be from left to right.